Welcome to topic number 9, normal distribution, and the last one in S1. And we are told that after completing this chapter, you should be able to use the normal distribution and its tables to find probabilities. There are tables that we shall use for this particular topic. One is in page 201, I think page 201, we will find it. And the other one is in page 202. We should also be able to use normal distribution and its tables to find mean, and we should be able to use the normal distribution and its tables to find standard deviation. But before we go to example 1 and to see how this topic is all about, I want to explain something in this very first video so that we can be in the know. And on page 176, let me explain what is there. And it said that if you think about the heights of your friends, it is quite likely that most of them will be around the mean height, which is 180 centimeters, if we take that to be the mean height. However, a few may be quite a bit shorter, and some might be taller. A frequency polygon of their heights might therefore be approximated or modeled by a distribution like this. Now, if you think about the height of your friends, most of them will be around 180 centimeters. Most of them, meaning that most of them will be there. A few will be shorter and a few might be taller. So you will have a diagram that looks like this. And of course, when we talk about now, this one is called the function of x because we are discussing height as x. Now, from here, if we call that 0, to the left, we have all the shorter people less than 180 centimeters to the left. And here, to the right, we have, these are the shorter people, and these are the taller people, and this is the mean of height, the mean of the height. We might come up with a diagram that simply looks like that. And this distribution is an example of a normal distribution. Normal distributions are important in statistics and are used to model continuous variables in many areas of life. It is therefore by far the most important probability distribution you will come across. Normal distribution, a very, very important topic, and also a very critical one in the whole area of statistics. Not only statistics 1, but wherever you'll be dealing with statistics, you must mention normal distribution. Let me say something that is on page 177 and under 9.1. And we're being told that you can use the tables to find probabilities of the standard model distribution Z. Standard model distribution Z. You will see Z many times, because Z, sometimes we shall be calling it the boundary for now. 3 points to note. Number 1, on page 177 and on top there, for a normal distribution, probabilities are given by areas under the curve in a similar way to which frequencies are found by areas under a histogram or frequency polygon. Need not to mention anything to do with the histogram, but you know the area of any bar in a histogram will always give us the frequency. And I want to compare the frequency, the histogram, with the normal distribution model and see how the area is used to give us probability. Point number 1, I'll demonstrate on the board. Point number 2, tables are provided to help us calculate probabilities for the standard normal distribution. We shall start using the tables as early as example 1. I'll show you how. Point number 3, the standard normal variable is usually denoted by Z and has a mean of 0 and a standard deviation of 1. The usual way of writing this is the standard normal variable Z is distributed normally, and we have had that the mean is 0 and the standard deviation is 1. Of course, when the standard deviation is 1, 1 squared, of course, gives us simply the variance. But let's see how. This one is explained as this one is the normal, this one is a boundary. The Z is simply the standard normal variable. The standard normal variable. The standard normal variable. This one is to denote that it is it is distributed. This one means distributed. It is distributed. And N, this one is for normal. This one is normal. And of course, you will see that the mu is 0, that means the mean, and the variance is obviously 1, which is the standard deviation, of course, squared. Let me explain something here. The mathematical equations for this curve is designed so that the total area under the curve is equals to 1. The total area under the curve, this one, or I may even come up with another one, the total area under the curve is equals to 1. The total area. This is Fz. For that matter, whatever Z is. The total area under the curve is equals to 1. From here all the way, or to there, the total area is 1. As the sum of the probabilities. Of course, you can remember when we are talking about the total area which is equals to 1, the total area is equals to 1, and the total probability is also equals to 1. You can compare the two. Both of them will add up to 1. I'll explain further. And so, the probability of a certain Z, the probability of a certain Z less than or equals to a certain boundary A will just be the area under the curve to the left of A. Let me explain this. Assuming A is here, that is our A, that is the boundary. This one talks about the area of the shaded region, the area of the normal distribution model to the left of A, because we are being told that Z is equals to or less than A. If we happen to have something like Z is greater than or equals to B, that one, and we happen to have our B there, then that one, this one talks about the area which is to the right of B, because you can see Z is greater than, meaning is to the right of B. So this one is that area, and for this one, you will talk of that area. And that is how we are going to establish our knowledge as far as that one is concerned. You can use tables or a calculator to find these probabilities. For now, I will encourage everybody to use tables. The calculators, we shall engage them later. You will find a copy of the tables on page 201 and page 202 of this very textbook of S1. The tables give the probability of Z less than Z. Let me just highlight it here. The table gives the probability of Z less than Z for the different value of Z. Of course, you'll see this on page 201. This one is what is explained in page 201. And sometimes, which is, this one is called phi. Phi is often used as shorthand for the probability of z less than z. So you will find some books writing this, but most of the books will always write this. And for our case, we shall be dealing with the probability of z less than z, where this z is, I will always call it the boundary for now. I'll call it the boundary for, so that you can understand better for now. And of course, we shall see what happens even as we start explaining example 1 of this particular topic. But this information is quite critical. Please note the probability is tallying with the area, and of course the area under the whole normal distribution model is equals to 1. The boundaries will be telling us where we are and exactly the value of z. All right?